Hello, everybody. So you're
Let me just get my thing.
sure, and that should be fine. I'm
in the
sharing
background.
this one. So good evening. Welcome to the February meeting of the San Francisco Bay Area Dynamo User Group. My name is Brian McCaffrey, and I am filling in here for Cesar with the announcements and this setup. So first off, you can sign up at sfdug.org. If you basically Google SFDUG, you'll find all of the YouTube recordings of these events, the blog, and all of that info. Today's speaker is Joseph Provenza. He's previously PB, now WSP, in from New York. Hopefully we'll give him a warm reception. Yeah. So just a few announcements really quickly. This weekend, starting Friday through Sunday, is the 5th San Francisco Bay Area Hackathon. So if you haven't done one before, you can create a team and register through Saturday, actually. Basically, it's a place for people who are interested in building cool tools in this sort of AEC built environment world. Cesar and Alberto actually, and I don't know, I can't see anything because the screen's in my eyes. There's Alberto. So basically, Cesar and Alberto have already formed a team that's a focus on augmented reality. So if you're interested in that, you can contact them. And I highly encourage anybody to do it. It's pretty fun. Additionally, there are a couple of different academia-hosted workshops and seminars coming up. So the first is this AI machine learning panel hosted at Stanford, and that'll be March 1st at 6 p.m. And then, as Cesar has also mentioned in the past, there will be several there are ongoing machine learning workshops up at Berkeley. So some really cool stuff going on there, and I highly encourage people to check that out as well. And upcoming meetings, we've got a bunch of really, I'm pretty excited about Joseph's presentation tonight. We've got a couple of really great presentations coming up. Paul Winter from Parametric Monkey is March 14th, just down the road, and Randy is coming to present April 18th. So without further ado, I'm going to hand it off to Joseph, and we can get started, jump right into it. There. So now you should, if you, cool.
Hello, welcome. Just before we get started, how many architects? Okay, engineers? Not so many. Construction, other? All right, mostly architects, is what I figured. So I'll probably skip through some of the engineering stuff. Okay. All right. So just a little bit about me. Engineer, architect, lots of school, too much school. Notice there's no years and there's degrees. Don't want anybody to know I spent 15 years in college, but in fact, that's what I did. I ended up actually getting licensed architecture and engineering. Currently at WSP, building structures in New York. Formerly, this was Legacy Cantor Scenic, which I'll have a few slides of what we do, but specifically in New York, we do high-rise structures. I also lead our global computational design group, a newly formed group, more of a knowledge-sharing group about split up amongst our offices around the globe. Joined WSP in 2006. It's been there, it's going on 12 years. Worked in a variety of offices, New York, LA, San Francisco. Spent about 6 months in New Delhi and a little bit of back and forth. So hopped around a bit, settled back into New York, I'd say 3 or 4 years ago. A couple of current projects. These are all New York projects. Being in San Francisco, these addresses aren't going to mean anything. This is probably my biggest current project, topped that actually 2 months ago. It's a 1.2 million square foot concrete residential project. And I like to show this one in context of this presentation, because this is the project that really forced me to get into computational design and to develop some of the tools that I've developed. Just the complexity of it, the rate at which it was developing, changes. I mean, I really had to use Grasshopper to kind of carry the project through. There really would have been no other way to do it efficiently. So this is one of the big projects I have going on. Again, it topped out a few months ago, and a few other small ones going on. All the kind of computational design stuff I do is pretty much in my spare time, if I can call it that. Extracurricular, at the end of the day, though, I'm a project engineer by trade, by practice. It's what I do. For those of you that don't know, WSP, how many have heard of WSP? Good, more people than I expected. At this point, WSP is about 40,000 people strong worldwide. Primarily engineers. We do have some smaller architectural pockets, built ecology and such, but primarily engineering, structures, MEP, it's what we do for the most part. In the context of New York, again, in New York, it was legacy Cantor Scenic, primarily structures. We do tall, skinny buildings, not just tall, skinny buildings, large, complex buildings. Okay, it's what our practice was built on and has been built on the last 40 years. WSP bought Cantor Scenic, I want to say about 15 years ago. And they've also bought a number of other structural engineers around the country, around the globe. But in New York, I mean, we're probably the premier structural engineer for a lot of the larger projects that you might recognize in New York proper. So what are we going to talk about? Computational design. I'll just briefly go through what our computational design group is. Just 1 or 2 slides, and then we'll get into visual programming. I'm guessing, show of hands, everybody here is Grasshopper, Dynamo, one of the two, mostly, right? No real software developers, I'm guessing. We'll look at how it's being used in the AEC industry, okay, and then as engineers, how we use it in practice. And I want to stress in practice, okay, because a lot of engineers, a lot of architects, you know, architecture and engineering is very different in that architects build their designs in a large part from the ground up using computational design tools. But engineers, it's slightly different, right? I mean, a lot of people can produce glossy images, develop some scripts, say they're using it day to day, but the extent to which you see an engineering firm using Grasshopper and various computational design tools in practice, I would say is very limited. It's based on my own experience. So I want to stress that this presentation is going to be built on practical examples about how we use it in day-to-day engineering. Okay, so just again, brief introduction. WSPnext is our computational design group, started a few years ago. I'd say at this point it's more of a knowledge sharing group. Okay, we do have a couple of in-house specialists we've hired, software engineer, a couple of software developers. We have some guys doing custom content development, custom script development, but to a large extent, our computational design group is a knowledge sharing group. So when I got into engineering many years ago, I knew of Grasshopper because of the school I went through, right? Again, it's built into the architectural pedagogy, and I knew of various people that were doing it around the globe, and then I just started to kind of coalesce the different people that were doing it. And again, once you start to tap into all of the resources around the globe, especially for such a large firm, you very quickly realize that there's an enormous amount of resource out there, right? And with computational design tools, Grasshopper, Dynamo, and such things of that nature, you know, the more tools you have exposure to, the more you understand what's capable, and the more you can kind of accelerate your practice. So our WSPnext, what we're calling, is built in, basically split amongst 2 separate groups. Okay, we have the parametric design group, okay, which is what we're really going to focus on, and then the application development group, which is really just ground up software development. Okay, and obviously, because of the nature of the business, there is some overlap. Okay, and what we'll talk about here is what some of that overlap is. Okay, so visual programming in the AEC industry, architecture and engineering. I'm sure everybody's here because they use this or want to use this or have used this to some extent, either in school or in practice. Can I show a few buildings here? Not necessarily computationally designed, generated, but I show them to highlight one of the problems that we're seeing more and more. When I say problems, I'm talking about a building that may be 60, 70, 80, 90 stories tall, but where every floor is different. Okay, and whether or not these things are generated with Grasshopper or Dynamo or not, okay, at the end of the day, as engineers, as architects, we have to deal with this, right? As engineers, this is what we're handed. We have a building where 80 different floor plates are different. Okay, 80 different floor plates have to be designed, 80 different floor plates have to be built, okay, and we have to work through that. Okay, and again, it's built into the pedagogy of architecture. Architectural design, modern architectural design is founded upon this to a large extent, right? And engineers following suit because at the end of the day, you know, whether we're working with architects from the beginning or we follow in after them, okay, we have to deal with these forms, we have to make sure they stand up, and we have to design them. Again, this is, I'm sure everybody's familiar with this kind of workflow, okay, or some form of this workflow. Okay, you're doing all your modeling, your heavy modeling in Rhino or Revit, going through Grasshopper or Dynamo, and then going into whatever other software you may use. For architects, maybe 3D Max, maybe Revit, and maybe any kind of lighting softwares. For engineers, it's ETABS, it's SAFE, it's your miscellaneous analysis softwares. Okay, but everything at the end of the day goes through Rhino, Dynamo, Grasshopper. That is kind of your medium through which you kind of utilize these tools. That's a key point to make, okay, because a big advantage to using Rhino, to using Grasshopper and Dynamo is it helps you link all these different disparate softwares. Now, whether you're an engineer or an architect, I'm sure we've all dealt with the workflow where you have 4, 5, 6 different softwares, spreadsheets, who knows what, and you have to get any kind of data, any kind of design into and out of those spreadsheets, right? And it's a disaster any way you slice it, right? And, you know, we have to deal with it, we have to cope with it, and this is a convenient mechanism to do that efficiently. Okay, so main paths in engineering, similar to the way it's used in architecture, right? Complex geometry, and when people think of Dynamo and Grasshopper, this is usually what they associate it with, right? Is addressing complex forms, okay? One-off projects, things that you're developing a script tailored to a specific project. And unfortunately, that's how people kind of typecasted Grasshopper, at least in the engineering world. Again, optimization, similar to that, okay? It's a one-off type thing, a project-based thing. Okay, but what we're starting to do more and more, and what I'm pushing from our end more and more, is interoperability, okay, and automated design and code checking, and then I'm starting the last thing, right, automating mundane tasks. Whether you're an engineer or architect, there's some part of your day, probably a large part of your day, we're just doing mindless things, copy and pasting spreadsheets, getting data in and out of different softwares, generating markups by hand, red lines, right, and that may be a large part of your day, but that's just kind of the act of doing your job, right? It's just there's you know, it's a mindless task, whether it be redlining something. And it's this last thing, automating mundane tasks, that's had the biggest impact on our office. You know, a lot of what we do is marking up, right? We pull data out of, let's say, SAFE or ETABS or any analysis software. We mark that up for a draftsman. We pass that along. And a lot of that is just fluff. Anybody can do it. You're pulling data out of one software and marking it up for somebody else to do it, right? And if you could automate that, which is a lot of what we've done here, is automate a lot of this. You streamline your process, and you can spend your engineering or your architectural design on the real problems, right? The real details of the design. So I'm going to go through today is focus on practical applications. Again, how do we use this in day-to-day engineering practice? Again, I'm going to use this by, I'm going to highlight this through case studies, right? There are going to be a few general slides, but what I want to focus on is the work of not so much myself, but more my colleagues, right? What have we done, WSP, around the globe, different offices, different practices, how have we taken these tools and integrated them within our practice, day-to-day use? Okay, so this is a good slide to start with. I like starting with this project for one reason, because it looks like it's very simple, very straightforward, a bunch of cubes smushed together. But when you get into the details of actually designing it, it's actually very complex, right? A couple different facets. I mean, the simple act of taking the geometry from an architectural model and building an analysis model, right? That's very difficult to do when you have something like this. Again, they're just cubes. Once you rotate these cubes, you smush these things together to meet at all different angles, okay, all different geometries. So how do you take this data, how do you bring that into your analysis, and then the bigger headache probably is how do you draft this? So you have a bunch of cubes, okay, 4, 5, 6, 7 cubes, then you have to flatten these and have to build these. All right, so what Andrew did for this project is, yes, he brought the architectural model through Revit, through Grasshopper, into his analysis program, right? And that was convenient with the design change. Okay, but the bigger advantage here was flattening this into production, right? And this is something that had to be done because they had to build this, right? And then when you flatten these cubes, okay, where all they meet at these intricate corners, You have to set that out for someone to build it, right? Hundreds of points, thousands of points, right? So that act of transferring a design from analysis, right, from your production tool, flattening it and making that something that's buildable is an enormous task. Okay, an enormous task, and even worse, when the design changes, you have to do all that again. You have to flatten the whole thing again, right? So what he did was he used this as a mechanism to generate a workflow, streamline his practice, okay, and then have a set of geometry that you can then flatten and feed straight into production. So that was addressing complex forms. Okay, another thing Andrew Pratt, our colleague in London, has done is use this for optioneering. Okay, so as architects, I'm sure you all know, you want to do more than one option. You want to study multiple options. Okay, for a tower like this, you use this for studying different column configurations, different die grid configurations. Okay, different floor plate layouts. Okay, and you want to see many different options, right? So traditionally, you're gonna have to do these one by one. Okay, you have to build the analysis models one by one, right? And you may present to a client 1, 2, 3 different options. Okay, but by using Grasshopper, what it was able to do is generate a workflow. We could generate a few different options, as many actually as the architect and client wanted. Okay, do the analysis on those options. Okay, and then present a number of different options to the architect and to the client. Okay, and then something simple like color coding, right, is also something you use Grasshopper for, and it's just a way of bringing data to analysis data that you can see visually. Similarly, interoperability, and again, this is something I touched on. As architects, I'm sure, just like engineers, you have data in very different, enormous array of different softwares, spreadsheets, whatever you may have. You have to get data in and out of different softwares. And the key thing here is Grasshopper, at least for me and for some of my colleagues, has been one of the only ways you can do this smoothly, right? You have Bentley, you have Autodesk, you have CSI, all different softwares, all different companies, right? And some of them have plugins, some of them have converters, some of them translate this data to that form. But at the end of the day, there's no one real way to carry one set of geometry through 4 or 5 or 6 different softwares and then split it into spreadsheets. There's just no way to do it without using some kind of tool that's been developed in Grasshopper. So our colleague in Australia is named out there because he's no longer with the company. What he did was he developed a workflow and a couple of tools that can use not only on one tower project, but then he can use this on multiple tower projects. Once you have that workflow set up that you've done, that you've run through a number of times, okay, you've learned your lessons, then you have that tool that basically fills in the gaps between all your softwares. Elliot Glassman in our New York office actually built Ecology. He's one of the only other architects in the building, at least in New York. And again, this is a similar slide workflow that you may have seen, you've all come in contact with. The parts are going to be different for everybody. Everybody works different. Everybody uses different software. But at the end of the day, right, this is, I'm sure, a workflow you're all familiar with. Now, for daylighting design, which is what Elliot does, okay, he does built ecology, he does daylighting design. This is not only a convenient way to get data in and out of things. It's not only a convenient way to optimize, daylighting design. It's kind of the only way he has to do his analysis, right? For daylighting design, he uses Diva, Honeybee, Ladybug. I'm not familiar with all of them. Okay, but they're the only tools he has at his disposal. So in the case of built ecology, and specifically what Elliot does, there are no other tool sets. Okay, this is the only real tool set. It's the only real production tool set that he has at his disposal to do his analysis, daylighting design. Okay, data visualization, similarly. Okay, I mean, you have enormous data sets. You want to present this maybe not only to your team, but to your colleagues, to architects, and eventually to the client. Right, so you have massive data sets. How do you visualize this data? Okay, so what he's done is he's developed a number of Grasshopper scripts so that on every project, he has a standard workflow he goes through. He has his climate data, and he can spit out in a few clicks of a button his climatic data, easily visualize what his parameters are, to then carry that through his design. Okay, and really there is no smoother way to do it than with Grasshopper. Okay, again, this is just an optimization. Okay, Elliot, again, in our Built Ecology group, does daylighting design. Okay, that's just optimizing different solar options, glare options. Okay, again, he's built his whole practice is built on Grasshopper. It's a project in Dubai. We actually also did engineering for this. Unfortunately, there was no computational design on the engineering end, at least on the structural end. Okay, but on the daylighting design, this is what he used. I mean, this is what he uses day to day. And again, I want to stress this. This is one of the rare cases in engineering where there really is no other workflow. Okay, and this is more architectural. But again, for him, there is no other tool set that he can use. Okay, this is for a tower in Mexico City. Okay, and again, one of these similar geometries. Okay, you have a tower, all four sides are sloping. The geometry may not seem that complex, but when you get into the nuts and bolts of it, every floor is different, right? So how do you take this kind of tower, and again, for this is one study for this tower, and there's actually maybe 10 or 15 different studies. How do you take that set of data, set of studies, feed that into your analysis, okay, do some optimization, and feed that end results back to the architect, right? So what Ilya has done is set up a workflow where you can taking a Revit model, actually this is generated from a Rhino model, feed that into his analysis tool. Okay, basically we generated an ETABS model straight from Rhino through Grasshopper, was able to optimize, okay, based on deflection of the tower, and then find out what the optimal place for outriggers was, what the optimal column layout was, okay, and then present these options to the clients. Okay, this is a feature stair in Hudson Yards, and again, this is one of the cases where, you know, there really is no other way to do it, right? You can't build a model like this in engineering software, at least not easily, okay, and let alone, you know, one model is very difficult to build, but when you have to build 5, 6, 7 of them, he's done 8 of these iterations, and I can tell you they're building it and it's still changing, right? So they have shop drawings and he has to spit out, you know, new vibration analysis. What does he do? He's not going to build a new model, right? He's going to feed it back into a script. By the end of the day, you know, he has an optimized design. He can change and update it as needed. Hudson Yards. This is a new tower in Hudson Yards we're working on. So what Joe Fiorello has done in our office, he's one of our BIM managers. Okay, he's done something that I'm trying to push onto all our clients. Okay, he's not come in after the fact as an engineer, trying to program a workflow, right? Trying to take something an architect has gave him and spit it into Revit, spit it into our, you know, our analysis tools. He's actually started with the architects from ground up, right? Developed a workflow so that he can very easily take any Rhino model they send him, okay, and basically generate all the columns, all the slab edges, all the grids, all the levels. Okay, so what he's doing here, okay, and this is important to stress that it's set up this workflow is set from the ground up, okay, so that when all these columns change, and again, this is still early on the design, so they're changing rather frequently, so it would take column center lines, able to take levels, able to take grid lines from Rhino, okay, and through Dynamo generates basically an entire Revit model, okay. Then he feeds that Revit model, that Revit model is then used to build our analysis model, okay, and this is still early on in the design. Okay, the level to which you take this as you go through production, that's another story, but early on in the design, this is critical, right? You're not going to build a Revit model for a 1,000-story building every time the architect sends you a new model, right? Or you're not going to want to, but this offers a convenient and easy way to do it. Okay, again, I want to stress that this is something we're trying to push more and more, right? The earlier we can get architects engaged, set up convenient workflows, right, through the project, the more efficient it is for everybody. Right, and then at the end of the day, it all benefits the client, right? So if you can set up these efficient workflows from the beginning, right, as you carry this through the project, everybody benefits, right? There's no losers here.
Can you touch base a little bit more about the interoperability between Rhino and Revit? And was it through Flux? How was the data feed from Grasshopper through
Could we go through questions at the end? Is that okay? Sure. Let me just finish. I have a few more slides, and then we can go through whatever questions you have. So as I mentioned in the beginning, automation, okay, is one of the biggest impacts in our office we've had. Okay, so we probably do in New York 40 million square feet of new construction a year, 30 million square feet, probably 75% of that is concrete. Right? Concrete is very labor intensive in terms of the design. You have load takedown, okay, you have flat slab reinforcement. So what this is showing is the old way, or one of the old ways, we used to do tributary area for a single column. Okay, this is going on a minute. Imagine this is sped up, so maybe 2 or 3 minutes for a column, right? For a floor plan such as this is I think 120 columns, maybe 4 hours. Do tributary for one floor, right? Times that by 40 floors, which again are all different. This is maybe a week's worth of work just to do your load takedown. Right? What I'm doing here in a few clicks, right, is then generating that tributary area, and I'd say less than a minute, right? Multiply that over 40 floors, and then remember this is going to change a couple of times. This has probably saved me months worth of time of recalculating all these tributary areas, right? And I want to stress that this is not something that's used on a one-off project. This is a script that we now use in all of our projects, or most of our projects. It's the most convenient, simple way to do it. There are other ways to do it, finite element analysis, different softwares, okay? But this is a workflow that can be used and it is being used now in all of our projects, a large portion of our projects. This is a CAD Revit based input-output. You're feeding data in through CAD, okay, you're bringing it into CAD, from CAD, right? That's where your data is coming from. Then we're taking all this, extracting it, and bringing it into our engineering analysis. Flat plate concrete, again, this is most of what we do in New York. When I talk about red lines, labor-intensive red lines, I mean, this is what I mean. So there's not many engineers here, but can somebody guess? There are a few that I know that are here. How many hours this would take to mark up for one floor? Give me a number, Michael. I know you can.
It's like 8 hours.
Exactly. This is an 8-hour markup, right? So this is an 8-hour markup. This is a full day design, right? 8-hour markup. There's some analysis done in there, right? You pass this to drafting, another 8 hours. This is a 2-day design, right? In New York, 2 days, like 2 New York days, so maybe 2 12-hour days, right? So what we've done was we developed a script, right? That will basically bring data in from our analysis, okay? Bring geometry in from either Revit or AutoCAD, okay? So you have all the parameters, and this will spit out at the end of the day, right? Basically 80% of your flat slab design, right? And this is for one floor. This maybe took 20 minutes to do, right? Obviously, there's still more that needs to be done here. This is some cleanup, you know, some finessing, some real engineering, getting to the details, but most of this is done, right? And this is one floor out of many. Okay, there's one floor out of 40 that are all different, right? So this is saving on the order of months, you know, a large percentage of the time that's spent doing just grunt work, just the boring stuff that you shouldn't be doing that a monkey can do, right? So why would we be doing that as an engineers, as architects, right? We can have this grunt work being done automatically. Okay, so I'll go through some engineering slides quickly. Long story short, engineering to a large extent, those that are engineers I'm sure can agree to this, is very subjective. As objective as you think it may be, it's still very subjective. Right? A lot of the decision making goes into it. What's not subjective, right, is code compliance, right? You have to comply with codes, right? And that's something that's, you know, every engineer knows. It's kind of, I don't want to say it's grunt work because it's not easy, right? But it's a large part of what we do, right? And why not automate this, right? Because there is no real decision making there, right? You have to be code compliant. You have to at least check your design, making sure it's code compliant, right? So why not use Dynamo? Why not use some software to do that for you, right? Obviously, we have analysis softwares, but if you want to go through a project and make sure everything is code compliant, right? There are engineering tools that we've been developing that can be used to do this. So actually, there was a tool set developed by one of my colleagues, Constantine. Got to put his name up here on the slide. Basically, what he's developed is a whole Dynamo library that has different parameters, different libraries. He's developed a Dynamo toolset which he's coded with different libraries for different codes. Okay, then use these as building blocks, like any parametric design tool, any computation design tool. You have all your building blocks, okay, and then what you'll go through, and this will go through very quickly, right? You check different code parameters. So this is something that's being done separate from Revit, okay, which I want to stress, it's kind of a different workflow, right? Because you're using Dynamo independently, but you are accessing Revit geometry, right? So it's a very different workflow than what most people are accustomed to, particularly with Dynamo, okay? But I think it's critical because it's using Dynamo in a very different way, using Grasshopper or Dynamo in a very different way than a lot of people are using it. You're not using it something that's just pushing and pulling geometry and doing things to other things. You're actually using it as a computational tool. Okay, you can do optimization, you can do computation, you can do calculation. Okay, and then you're grabbing what you need to from the Revit model, from whatever model you may have. Okay, and then you're just plugging that in. So you're benefiting from a 3D model, but you basically you essentially have a different computation tool that you can do. So a lot of what's being done on the side here in Dynamo stuff we typically do by hand, or we typically feed into 5 or 6 or 7 different spreadsheets, compile all that data, and at the end of the day, yes, we determined this is code compliant. Okay, but now we have a library that we can use that's easily at our disposal, that can be easily customized, okay, that we can use our day-to-day calculations. Okay, another example, more of a general example, not so much of a specific project, but again, using Dynamo to get data into and out of an analysis program, right, to inform your Revit model. All right, so again, as engineers, we use a couple of different tools, a couple of different analysis tools, ETAB, SAFE. Okay, but what we're doing here is we have our Revit model, we have beams on our Revit model. What we're doing is setting up a workflow where we can pull data out of our analysis program, right? In this case, is beam forces to make sure we can size beams appropriately in Revit. And then that's all tied together so you have something that can be live if you want it to be live. Okay, so what I've done up to this point is what we've been doing around the globe to various offices, computational design, what I mean by computational design is Grasshopper, Dynamo, parametric design. Okay, the other aspect of what we're doing is ground up software development. And this is real, actual, what it sounds like, software development. You're not really leveraging any computational design tools. You're doing hardcore coding, right? So what Constantine is doing in our office is developing a whole custom tool palette, a whole WSP, very structural designers, WSP software. It's basically codifying all the engineering calculations that we've up until now usually been doing primarily in spreadsheets. Okay, I don't want to show too much. I had some videos, but a little bit sensitive. At the end of the day, we're building a whole custom library. Okay, so Constantine is doing in New York is basically ground up software development. Okay, and the flip side to that is kind of a half and half, kind of a hybrid. Right, so you have some script that you've baked, that you've developed in Grasshopper and Dynamo. Okay, but you don't necessarily want to dump a Grasshopper script on somebody that's been doing engineering maybe by hand for 30 years. Right, you give them a thing with a bunch of plugs. You know, it's very difficult to get that into your day-to-day workflow. So what can you do? You can develop a software that runs that in the background. Okay, so you benefit from having all the tools at your disposal. Okay, you have Grasshopper, you have all the geometry features that are there, and pushing and pulling of your data. Okay, but then you put that, basically associate that with a front end that's been hardcore developed. Okay, so you have some custom content developed on the front end, but the back end, we're still accessing Rhino, we're still accessing Grasshopper, we're still accessing Dynamo. We're just putting it in a more digestible form for the larger engineering community, at least within our office. The one on the left is actually just a spreadsheet, but it's a cleaned up, kind of idiot-proof, dummy-proof spreadsheet, right? That can not only be used day to day, but it's also something that's always going to be up to date. For those of you that have used spreadsheets, what's the worst part about a spreadsheet? You take it from the drive, you save as, then you have 20 different engineers, 20 different spreadsheets. Who knows what's current anymore? And one of the benefits of doing something like this is you have a spreadsheet that every time it's open, it's going to be the most current. Okay. Also, we've taken some of our Grasshopper tools. Again, you don't want to dump that onto somebody that's been doing engineering a different way for the last 20 years. So you just make it a little bit cleaner, a little simpler, a little bit more digestible. So what's next for us? We haven't done much with this, but at the end of the day, I mean, artificial intelligence, at least in my opinion, will be the next paradigm shift we'll see probably in 3 to 5 years. I mean, there's a lot of AI going on now. It's been going on for many years, right? But it will start to make its way into our workflow as BIM did 10 years ago. It's important to at least have a slide on this, even though we haven't done much with it, right? Because you have to recognize where this is all going. At the end of the day, this is going to mass data consumption, mass data manipulation. That's all artificial intelligence, right? And the biggest problem with BIM adoption 10, 15 years ago was, at least for engineers, it was a completely different workflow. The architects have built from the ground up, from school, 3D modeling, 3D doing whatever you are, it's always going to be in 3D. You think it's 3D, and as an architect, you're always working in 3D. When BIM came into engineering workflow, though, many years ago, engineers were traditionally trained more in a 2D fashion, more in a linear fashion. So BIM kind of turned engineering upside down, right? And we're still kind of, 15 years later, we're still coping with it, right? It's just a very different workflow. And artificial intelligence, we'll see a similar shift, right, into a very different workflow, again, in the next, 3 to 5 years, maybe it'd be sooner, maybe it'd be longer than that. Okay, but that, at least if you ask me, this will be the next big paradigm shift. So, questions? You asked the first one, so what was your question again?
It was one of the New York projects that I don't remember the name of. Okay. And I was wondering if you can give further details from a technical standpoint on how was the data transferred to Grasshopper.
Okay, so we have column center lines. It was a Hudson Yards one. We had column center lines. Okay, we had levels in Rhino. Okay, we had, I think there was grids in Rhino. We had slab edges in Rhino. So all that data was taken in Rhino. Okay, and then I believe it was using Dynamo, through Dynamo and Dynamo. Each of those distinct elements was taken through Dynamo and brought into Revit. Okay, so then it was taking column center lines, generating column families. It was taking slab edges, generating slabs, levels, grid, and so on, generating all that model from scratch. That answer your question? Good. Yes?
I think in one of the slides we're creating a RAM model from Revit. Mm-hmm. How that works?
RAM I'm less familiar with. Okay, I haven't had much experience going back and forth with RAM. Typically, we would take the wireframe, right? Whatever software you're going into or coming out of, at least for RAM or ETABS, it's going to be through a wireframe. right? So that would be the mechanism. You either take a DXF, 3D DXF, or 3D DWG, and use that to generate your wireframe and feed that into your analysis model. It can either be through, I think we've done it through text files, and point files, CSVs, and a couple of different ways we do it. RAM specifically, I'm not too clear, but I know the general ways in which we get data in and out. Does that kind of answer your question? So some of this stuff is not stuff I personally dealt with on day to day, so I can give you a card and drop me an email, I'll get you a better answer for that. Yes?
You said you have about 40,000 employees?
Worldwide WSP, yes, about 40,000.
What's the percentage of people that are currently using computational design, using Grasshopper? It's a fairly small percentage of the office. If it is, maybe bigger than I think.
I'd say very small. I'd say, and this is part of the group that we've started, the working group, our WSP Global Computational Design Group, right? Excuse me, is we've found, and this is just by word of mouth, I mean, in each big office, there's at least one or two champions that know one of the two softwares, whether it be Grasshopper or Dynamo, right? So in all the major offices, I'd say there's at least a few, but it's a very small percentage, right? And we're trying to change workflows to feed this into the larger, for larger consumption, right? So we've done that in our New York structures practice, and now we have larger percentage of engineers using this. But I don't know that that's the norm. I don't think that's the norm, right? And typically, we have again a few engineers that have done this, championed this in each office. But again, we're trying to broaden that a little bit. But it is a very small percentage.
And that was going to be my next question: is do you guys have a methodology to sort of to expand that knowledge base to the rest of the offices, like sort of an active learning platform for the rest of the employees?
I mean, that's been the toughest part. So in New York, we have 2 or 3 tools that we've developed that we've kind of pushed out for everybody. This is the way you should be doing it, right? So the way we've done it is we've developed documentation. So we've developed comprehensive manuals. So I'm sure, as you can imagine, for engineers, everybody wants to know how the calculation is being done. So we have comprehensive manuals, then we have cheat sheets. So there's the comprehensive manual if you want to know exactly what's being done, and then there's the 1-page cheat sheet for someone that just wants to open it, go through, and press the buttons and get what they need. Okay, so we have manuals, then we do trainings. So for each of the tools, so for the 2 tools that we've developed for concrete, we'll do a lunch seminar. Okay, we'll do a few trainings, and then we'll just address questions as they come up. I mean, but we're trying to formalize that workflow, right? And we're doing similar in other offices as well. It really depends on what tools you've developed, right? And how many people are going to be using it. But I'd say training and documentation are the 2 most important things. Documentation probably being the most important thing. Right? Engineers, architects in the office late at night, you want to have a document you can just go to when you can't get somebody right in front of you.
Hey Joseph, we've got a question from myself online. He was asking about if earlier you had mentioned code checks specifically. So he was wondering how exactly you're doing that.
Okay, so one of the examples we use, and something I've used also myself, is, for example, some of the AISC design guides, right? We've codified that, right? So the AISC design guide, let's say for web openings, right? We have a package in Dynamo that basically codified all the checks you need to do for web openings and steel members, right? So we'll take some of those design guides, codify that in Dynamo, and then you have a package, and then you can kind of plug in the different parameters. Right, so that's one example, and we're doing other things along those lines. Yes.
Do you have a plan for introducing this when it first rolled out, as far as having it be accepted by principals or whatever that may be not as familiar with it? Do you have to start with like a portion of a project and then move on?
It's been difficult. I'd say in the last few years it's been difficult. Right? It's kind of the chicken and the egg type thing, right? You want to get support, but to get support, you have to show progress, right? So the way everybody that I know has been doing this has kind of been doing it on their own time. We try and charge very few project hours. I spent probably hundreds of hours of my own time developing some of these tools, and finally we have something that at the end of the day, the bottom line, you see it in the multiplier that this has been a big, this has changed. This has been something that has brought more money to the bottom line. That's when they start to listen. And again, that's why I said some of these automation tools have had the biggest impact, right? Because it's undeniable. I mean, you're saving hours, weeks, months of time, right? That's the thing to me that has had the biggest impact, because it's got the most attention, right? And you have to have that attention. Right? So these small things where you're doing one-off things for a building, unless you're going to make it something that's applicable to projects after that, it's very difficult to get that following. You need to have something that you can say, okay, you can use this on 50% of your projects. You're going to save this amount of money, right? And you're going to become that much more efficient. That, money speaks, right? So you have to be able to display that, at least in my opinion, right? And then there are the cases where there really is no other way to do it. There are some discrete structures, that there is no other way to generate a 3D model, right? And that's just something that there's no other way to do it, right? So they may come to you. How can I build this ETABS model, of this bridge structure, right? Then you have to give them the answer.
I have a couple of questions following up on a couple of these.
Mm-hmm.
So just out of curiosity, so is this is all being driven by your team?
When you say your team,
so you mentioned there are two different sort of like streams that have been developed internally within WSP with respect to sort of like within the sort of computational realm. One being sort of, it sounded like more project specific, one being sort of infrastructure grade, like actual software development type work. And so what I'm curious about maybe is sort of building on some of these questions is essentially, I'm just curious, like, is it a small team? And like, how many people? So like, when you're developing software, right? Like, as you're developing software, you need sort of like standards and rules so that things can work and don't break all the time. And sort of who's managing it, and how do you guys tackle those kinds of problems? Is my question.
So that's where the two branches go, right? So you have software development aspect, and you have the more Grasshopper Dynamo. The software development has to be what you just said. It has to be small teams that have standards, right? What we've done, what some fellows in our offices have done is developed libraries, C# libraries, a very specific way they need to do things, right? A very specific way things need to be organized, and that's a very small team. When it gets to Grasshopper and Dynamo, it's more, I'd say, open source, right? You have more of a mass developing things, right? And where you see overlap, you start to push and pull different tools where they may be applicable elsewhere. But in terms of software development, it's very niche, right? Because it has to be compatible with one another, right? So
that's now like a formal group that WSP is like, we care about this.
Yes. And again, we've hired now recently a few dedicated people. So we went from having just people doing this in their spare time to then hiring a few people that do this full time, right? And then hopefully we'll grow from there.
I guess last stupid question is.
No stupid questions.
It's a leading question. Do you think that's kind of essential at the end of the day in order to actually push the needle So I think in the room between 65% roughly gauging your questions at the beginning, architects versus whatever, maybe 25 and engineers and miscellaneous, I don't know. But the point is, like, with that sort of breakdown of different firms of different sizes, both of us work for larger firms, but I don't know if that's true for many of the people online. And so I'm curious, I want to make sure that there have been some other questions about like sort of like how you might advise people better implement things in firms of various sizes, basically.
I mean, if you ask me, it all goes to something that's workflow specific and applicable to more than one project, right? It's got to be something that can be used elsewhere. If you're doing something that's only going to be on one kind of project, it's very difficult to get buy-in, right? It's got to be, I mean, this is a different way of working. It's got to be a redefinition of a workflow that you can apply to an office to make it office standard, right? You have to find out where those, everybody works differently, so you have to find out where those gaps may be, right? Does that make sense? It's a difficult thing because it's different for every office. Yeah. Yes.
So it's interesting that you're saying it's always a challenge to convince the stakeholders at a company that this is something worthwhile. And I have heard it from smaller companies to bigger companies and so on. And at the end, would you think it makes more sense to have like a fund from whatever revenue that company has to just give these people to support them full to pursue all of the design intelligence, design technology efforts versus charge them to the projects, because that's usually the second path, is the path that usually people take, but that leads to people not really being able to innovate and, you know, last minute trying to find scripts over the internet and kind of like adjusting them a little bit. And what has been the, you know, path that WSP has taken so far?
So again, we've started as it's all been either project or on our own time, and then we've gotten more to the point where we're getting buy-in, right? We're hiring people, and you kind of have to do that. But at the same time, it's difficult to bring in outside team members, right? At least for engineers, you know, you have to have gone through that design process. You have to be very familiar with the company standards to develop anything, right? So there's also the problem of, okay, you hire a bunch of people, they don't know the company standards, they don't know how you do calculations, they don't know your design methodologies, so it's also difficult. So there's like a balancing act, very, very precarious balancing act, right? Because you go the wrong way and it doesn't work. It doesn't work at all, right? It's got to be, I mean, at the end of the day, I think it has to be a mix of the two, right? You're never going to have a whole team that's bought in, right? You're never going to hire a whole team from scratch to do this. I mean, maybe you can, but it's going to be very difficult. You have to have that informed from within. Yes.
So, through this computational calculation, do you actually reduce the amount of material that goes into it?
I'm sorry, can you repeat that?
Does it reduce the amount of material, structural material, that goes into the so save the cost of the project?
At the end of the day, yes. If you're using it as an optimization tool, then you have an optimal design. Then yes. I mean, that's as engineers, that's where we want to get to, an optimal design. Right? And a lot of times that's where we start. And, you know, you got to move. You know, optimal design is not always optimal architecturally. So you start from an optimal design engineering-wise, and then you push and pull and have what you need to. But yes, I mean, if you're using it as an optimization tool, then yes, there should be a reduction in material.
You have to take the bin direction, slim it down, fashion.
Well, that's part of the optimization kind of path, right? So you generate a few models, you have the computer generate a few models, and the script will tell you which is the most optimal engineering resolution, right? And that will be the optimal design. So yes.
And so that's compared to, let's say, a regular design. So they subtract it to say so many dollars.
Yeah. And the benefit here is it allows you to go through as many iterations as you want, right, to get to that optimal design. You can do the same thing traditionally, but you have to do all that kind of manually. This allows you to spit out, if you want to, 10 different variations, and you can easily get to the optimal design. Yes?
You could do that with Dynamo.
Excuse me?
I know you could do that with Grasshopper, but can you do that with Dynamo?
Not so familiar with Dynamo. I'd have to, I'll give you a card. I'll get back to you with a better answer. I know Grasshopper is a very robust library with Galapagos and all this that I've used. Dynamo, I'm not familiar, but I'm sure there is some package out there that somebody's developed. I mean, it's gotten to the point. I mean, when I was learning Grasshopper years ago, Dynamo was too early on. There was not enough data. I mean, now I think it's to the point where anything you want to do, that has been done in Grasshopper, you can probably do it in Dynamo. I think we're at that point, at least from what I've seen so far. Yes.
This might be off subject too. I know Vectorworks also has something that is like Grasshopper and Dynamo. So do you guys use Revit because your firm uses it? Because what you have been showing is Rhino Grasshopper analysis programs. And if you guys did use Revit, will you guys have stopped there?
We use Revit because at the end of the day, we follow suit, whatever the rest of the design team is using. The last Vectorworks project we did was maybe 12 years ago. I can't even remember. I know we did one a long time ago when I first started. But again, we're using Revit, not just because it's the industry standard, but as engineers, and we're following suit with the rest, really the architect. I mean, they're telling us we're using Revit, we're using CAD, we're using some other software. I mean, we have to be on the same page as them.
In your experience, what's the most efficient way to bring writing geometry as native into Revit?
I mean, my colleague's been using, I guess, Dynamo through Dynamo. There are a few packages for Grasshopper, a few plugins for Grasshopper that allow you to bring stuff right into Revit. When I used them, they didn't work so well. But I think,
Revit, for instance.
what?
Like Revit, for instance.
Yeah. I don't remember the name of it, but I know I used a few plugins straight from Grasshopper. But my colleague Joe, that's been doing this for some time now, he's gone through Dynamo. He said it's the easiest way. Right, so I know Dynamo and Revit. I think at least production-wise, it probably makes the most sense.
I have a question about where you're headed next. And I don't know if your Grasshopper training was like formal education training, or if you have to teach yourself about, maybe almost everybody here is outside of school and their technology is always developing. And we're always going to be like, checking out the innovation and trying to stay on top of it, but it's going to be changing constantly. And I'm kind of thinking, with kind of like CAD, and then there's some of the older people in our office who can do Revit or CAD, and they do more of the senior stuff. But I think in our age, or for my generation, the technology is going to even progress at an even faster pace than CAD and BIM and all that. So, what would be your advice, and kind of you're already thinking ahead with the artificial technology and how it's going to hit our industry, and how are you preparing yourself to be at the forefront of that and to stay on top of innovation and not kind of just take a senior management position?
It's tough for me. I mean, it's been tough for me because you get bogged down with projects and all that time I spent learning Grasshopper and developing tools, and it's hard to find the time, but you kind of have to make the time. I mean, at least for me, I'd say if you're talking about artificial intelligence and all this kind of stuff, that's more of a data mining, mass data, and it really comes more into a software development type atmosphere. Right? It's coding, but more robust, right? And I'm sure there will be some packages, some plugins for Grasshopper, for Dynamo when you're getting into AI, but I haven't really seen that yet. It's a hard question, right? It's hard to stay on top. And I find myself, right, and I learned Grasshopper, and like I said, when I learned Grasshopper, Dynamo, there's nowhere where I could use it because I couldn't do anything I could do in Grasshopper, and now I'm at a place where I have to learn Dynamo because it's where the industry is going. And eventually, I mean, because of what we do, Autodesk has a monopoly. You got to understand Dynamo, and I'm kind of forcing myself to get into it, but not really because I want to, because I have to keep up. Right? So for me, the next step is to master Dynamo like I've mastered Grasshopper, right? Because that's where the industry is at now. But where is it going beyond that, I'm not so sure. Right? But again, I think it's getting into AI, and it's getting into more mass data consumption, right? Data mining and things of that nature. It's a tough question. Sorry, best I could do. Yes.
So you talked about the sort of the old timers, the guys that have been doing, engineers that have been doing what they've been doing for 30 years, 20, 25, 30 years. Have you had pushback from them regarding the software that you guys have made?
Yes and no. I mean, first thing, we try and call them old timers. We say the more mature engineers. Yes. At the initial stages, yes. But then when you show them a tool that can do something that they've been doing, if you could do it in a fraction of the time, they're going to be receptive. Right? At the end of the day, it's going to make their job easier, it's going to make everybody's job easier, and it's going to allow you to spend your time more wisely. So there's been pushback, but it's, at the end of the day, everybody's been receptive. Right? I haven't run into the case where somebody just stamps their feet and say, no, I'm not doing this. Right? Because at the end of the day, it's for the best, not just for you, it's for the better for the company. So it benefits everybody, and it hasn't been. I expected a lot more pushback from some of the engineers that have been there for a long time, but there really hasn't been much. And again, because you're showing them just a better way, right? Right. If somebody's so closed-minded they don't want to be receptive to a better way, then that's another problem, right? Yes.
So the program would be setting up a sort of set of calculations, right? Then you send it to the building department, they have to check the calculations. So do they use the same programs to check everything?
they don't use Grasshopper to check it. I can tell you that much. Any calculations you send have to be in whatever native format they ask for, right? And that's another problem. So how do you generate that native format that they may want? Right? It has to be a report. You know, you have to submit a report. Then you have to take that data and transcribe it into a report. Again, I've seen people that will generate a set of calculations, then you generate a way to output those calculations so they can be fed into a report. Maybe even generate some of the report for you. But that's another piece of the puzzle, right? It's how do you take that data, you have your calculation set, you have to generate, right, the appropriate output for it. But no, building department is not using any of these tools, right? So you're stuck with whatever they tell you need to submit, right? And that's just another layer at the end of the day.
I have another question from online, and it might require some elaboration, but let me see if I just read it. Someone's asking, concerning computational design processes with respect to optimization, how do people here usually deal with the curse of dimensionality? We generally say we will do parametric design optimization, but we rarely ever look into detail in our design spaces. What do you resort to experience when you're facing the usual limited time and project constraints? Do you know if anybody is working on bypassing this issue? Are you familiar with it? Send me a Wikipedia article.
That's like a manifesto question.
Yeah, so part of it is temporal, I think, and please correct me in the chat there if I'm misunderstanding your focus of interest within this wiki entry, but essentially, yeah, basically part of it is sort of like 4D, 5D, and part of it is just simply when you're thinking about, I think his question is asking, when you're thinking about design space as the range of considerations that you have to take into account kind of exponentially increases each. I think of it maybe at least in terms of design phases. So it's one thing at concept, and then at SD when some of those things start kind of settling down, and then as you take in, you actually start explicitly checking, doing code checks and things like that. Past the sort of first principle, I think, level stuff. As you get into the weeds, basically, I think this is a question what. And all of those considerations increase. Have you found that essentially these tools are still applicable in those later stages? And correct me if online here if that's not the gist of it.
That was a very good synopsis of that long-winded question. At the end of the day, really, you have to be cognizant of that when setting up your workflow. So there are some things that, some of the tools I showed, for spitting out DD level models, right? So that you can submit a DD set, right? We get, but you're not going to do that for 100% CD because all your tags will go away and all your nitty gritty things will not be there. But there are certain places where I found, for example, some of the concrete design that you can't spit out a whole design, but you can compartmentalize it. And you have to be, again, cognizant of that when setting up your workflow. Okay, so I can do this now. I'm not going to be able to regenerate a whole floor further down the line, but can I set this up in a way such that if I want to just take 4 bays and redesign this without doing the rest of the floor? How can I build that in? Right? We've done that to some extent with some of these tools, but it's really specific to your workflow and how you set it up. So not to turn it back around, but you have to develop your workflow such that it's conducive to doing it at a later stage if that's what you want to do, right? And you can set it up, again, if let's say it's a steel project, you have your geometry set, you can set it up a way, and we've done it to some extent on certain projects, where you're tying your analysis to your steel, so as long as you're not changing steel and swapping out, you can easily change sizes. You can change reactions, right? But and that's a workflow decision that was made. Okay, I've set up my model, I'm not changing the geometry, I know the sizes are going to change, I know the reactions are going to change, right? So I've set up that specific workflow so that I can easily swap out those things all the way down through to the end of the design.
To piggyback a little bit, I guess, maybe this is too easy and unhelpful, but depending, like you were saying, depending on how you're doing it, right, you might run into issues where you're tracking GUIDs and then or not, and then things break. So so you guys, I think that make sure that I get it what it wants. I guess that you guys have figured out ways to constrain the number of things it's checking for.
Yeah. And some of the this is more particular to the stuff that's being developed from the ground up, the software. I mean that's developed in a way so that you can use these tools throughout the duration of the project, and it's by checking object IDs, and it's very robust in what you're checking, what you're deleting, and what you're replacing. It basically does a match, just like GitHub, the way that's oriented. I mean, it's doing that kind of level of analysis on the back end, right? So you're carefully tracking what's changing, right? And again, that's all workflow, and again, this is more conducive to a software development type thing, but it's there, and you have to be, again, aware of that and aware of that constraint, what you want to do with it. Maybe I'm just repeating the question. I don't know.
No, he's
okay. All right. Anybody else?
When are you coming back to the Bay Area?
Whenever I get invited. Yes.
Are you looking also for, let's say, game developer in your firm, or there is some initiative to integrate also this kind of feature in your workflow, or have you never spoke about this?
We have a VR setup because we have the BIM models, right? Every project, or I'd say most projects are in 3D. We have the models, so yes, we've experimented with it. It's been a little clunky at best, not fully integrated. We have the setup. I don't know that we've done much with it yet, but yeah, I mean, we're going that direction. Again, that's the direction the industry is going. Right? Particularly with some of the complex projects, we want to visualize these things in real 3D, like in the space. It's there. We're going that path. I mean, it's still early in the stages, at least for us, in terms of adoption. So yes, it's going that way.
Following up really quickly on Alberto's question, are you guys doing this exclusively, both of those streams you were talking about, out of New York, or are you guys going to be doing it here in your office over there as well?
Streams? What do you
like
mean?
in terms of all of this, like the software development and the typical CD kind of Dynamo, Grasshopper, yada, Icon, whatever.
I mean, it's being spearheaded where the experts are. So in New York, for example, is where the Dynamo and Grasshopper guys are for the most part. We have some software developers. We have one in New York and then one in Chicago. So it's really where they are. Again, we're hired a few specialists, but it's where they already reside that they're being utilized, right? I mean, we're a global firm and we work that way. I mean, we work day to day with different offices as needed, where the resources are. We don't want to be in a position where everything's taking place in one place, right? You want to be. Yes. Yes.
I have a question. I'm trying to think how to phrase it. This is going back to what you said. Being a global firm, do you find that there are certain areas, say Chicago, New York, San Francisco, Dubai, Tokyo, wherever, that are a little more heavily focused on people that are learning Grasshopper, right? So, for instance, have you guys found that there's a more of an influx of people that like to do C# in San Francisco for your firm, or people that are like to do Grasshopper in, pick a location? Have you found that? Is there sort of an even mix, or do you guys take that into account at all, or really, is it really just sort of location agnostic and you don't care? You could be in Timbuktu and it really doesn't matter. You guys don't care at all.
We don't. No, I'd say we don't really care. I mean, the resources where it is, and again, we meet. I'd say once a year, our group meets in person. So we have people coming from overseas. I'm talking about our computational design group. So we have people coming from overseas, people coming from different parts of the country. We meet once a year in person, kind of go through what we've been working on, what's being developed, and the rest of it's done via Skype. We have monthly meetings. So it's really divorced from the location. right? Saying being in New York helps because we're in front of some of the higher ups. I mean, New York is kind of a big part of our leadership, so it helps being in New York because I have direct access to some of the leadership. But I'd say it doesn't need. It's just the way it's shaken out. I mean, it helps, but we definitely have more location agnostic, I would say.
Right. And so I guess to follow up on that, have you found that clients, same question, but target to the clients? Like, have you found clients that'll buy into your system, the methodology? Are there more clients that are they're much more willing to buy in certain parts of the world, San Francisco, New York, wherever, as opposed to other clients that there's a little more catching up to do for. You have to sell your program a little more to someone, to a client, a developer, and take your pick.
I mean, I'd say in terms of engineering, each part of the country and the world works differently, right? And they work the way that part of the country or the world works. So in New York, we work the way people typically work in New York. So yes, you have to sell it. You don't have to sell it too much because everybody in New York, at least in the architecture and engineering community, work similarly, right? Selling a New York workflow to somebody in California or Chicago is tough because they work differently. Chicago, for example, uses different analysis software. They do different kinds of construction. They do more PT than flat slabs. It's just a different workflow, and it's just a different way of working. So you may not be able to sell the New York workflow to someone elsewhere because they do something completely different. So it's very location specific, and that's just industry. I think that's more based on industry than anything. Right? In my experience, there has been little overlap globally. I mean, we're trying to see where there are overlapping tools. The biggest benefit we've had in our working group is how to implement these things, right? Okay, what is the proper way to implement a script, right? We do documentation, we do training. That to me has been the best outcome of our global group, more so than tools, specific tools, because again, everybody works differently.
What's the number one thing you wish you could change in your process? Like, what's the thing you consistently come up against? Say, for example, it could be technically specific. So if you don't do as much PT in New York, or especially, let's say, specific to these, super talls or tall buildings.
I change the architects. Honestly, as an engineer, and again, I'm joking, but we trying to push this more. Early, we can get architects on board and develop those workflows from the beginning. That would be the one thing I'm pushing as much as I can, and it's hard to find the right clients, the right architects that are receptive to that. We are finding them, but I mean, if I could change anything, I would say that this is the way we're doing it from day one. Get us onto the design team. Let's develop these workflows, understand how our process is going to go from day one, and not try and do it after the fact. All right, we're seeing that more and more, but the more earlier we can do that, the more everybody down to the client will benefit.
And related to that, do you ever collaborate with the firm, architectural firm, for a competition from that starting point?
I have, yes. I have recently actually a couple of competitions that bring us on board just as an informal, what's your take on this? What do you recommend? And yes, I mean, they come to us because they kind of want that depth to their submission. And I'm always receptive to it. Even if we're not going to get paid, I don't mind. It's my bias because of my background, but I enjoy that. I mean, I definitely push that as much as I can whenever that opportunity arises.
There aren't any other questions online. I just want to make sure, we get everybody online. But there is just in the nick of time from Australia. Just props from internal WSP people saying they're excited to work with you and use this stuff. So on that note.